So we're going to talk about really exciting things today. If I can get my slides to work, hold on just a second. Figure this out. Google Slides, I don't know, I'm still working on it. We're going to talk about the magic of reactive programming with RxJS. So how many of y'all have heard of reactive programming? Hopefully everyone, yeah! Oh, I love the energy right now. Okay, so how many of you all actually get to practice reactive programming though? Not a lot? Cool, well this is why I'm giving this talk today. My name's Tracy. I'm the co-founder of a company called This.Labs. We do JavaScript consulting and a lot of stuff for the community, just bringing the general JavaScript community together. I'm also a Google developer expert on the RxJS core team. I do community relations for Node at Node Foundation. Oh my God, I do too many things. I just joined the Vue Vixen's board of directors, which I'm excited about, and do stuff like Google Women Tech Makers Lead, et cetera, et cetera. So that's fun, but I'm here to talk about reactive programming. And one of the reasons why I wanted to give this talk, I decided to do this late last year, was because I was surrounded by all these people doing reactive programming. I was like, what's that? I want to learn it. Anyways, but let's go through the explanation. So Wikipedia has a long explanation. This is 3 slides, so we'll go through it together. It says, reactive programming is the programming paradigm concerned with data streams and the propagation of change. This means that it becomes possible to express static or dynamic data streams with ease via the employed programming language, and that an inferred dependency with the associated execution model exists, which facilitates the automatic propagation of the change involved with data flow. So that's like a lot of words. But in layman's terms, kind of what they mean is basically reactive programming is dealing with sets of events over time, and it's the automatic or implicit, not explicit propagation of change. And each step doesn't really know or care about the previous step, and each step, all it wants to do is just perform an action when it reacts to the incoming change. So if you look at Excel, for example, this is like the most basic example of what reactive programming is. The first line is just going to have A, B, and C, and then D concatenates A, B, and C, right? It doesn't actually care what A, B, and C give it. It's just implicitly propagating itself. And then if you look at the second line, if you see I can change C to reactive programming, and then D just concatenates, and again, it's sort of the implicit propagation of data that Excel shows you. So we're going to talk about a few things today. First thing we're going to talk about is reactive programming and standards, then reactive programming in different frameworks and libraries, how to actually think reactively, because that's one of the biggest, most difficult things to think about. What is RxJS and how it actually makes development a lot easier. So let's talk about reactive programming and standards. So in the past few years, we've seen the standards bodies begin to sort of consider and adopt different reactive programming paradigms. In TC39, we have promises and observable, and then in WHATWG, we have the event target observable proposal. So if you look at promises, they were added to browsers around 2014, added to Node around 2015, included in the official ES 2015 spec. They're push-based, single value, always async, eager, stateful. They have a simple base API and obviously like simple transformation options like then and catch. If you look at this code right here, yay for a big screen. So this is reactive because it allows you to process a value asynchronous and in steps through then blocks, right? So I'm just using the fetch API here, and then I'm chaining to fetch a JSON file, and then I'm chaining together promises to parse a JSON file into a JavaScript object, and then console logging to signal that I've completed the parsing and I have fruit snacks. So again, a lot of people don't realize that promises are actually reactive because most of the code you write to interact with them actually isn't. But there you go. Y'all are reactive programming. Okay, observables. So this is at stage 1 in TC39 currently. RxJS is a reference implementation of the TC39 observable proposal. It has a simple base API. It's push-based, multiple values, synchronous or asynchronous, generally stateless, and it has a lot of transformation box options out of the box, like using something like an abstraction like RxJS. So over here, this is what general use of observables would look like. So here I'm just using the Ajax utility from RxJS to get the JSON file, fruit snacks. And then I'm subscribing to that JSON file so I can go ahead and emit the values from that observable. So the other cool thing about observables is that they're lazy. So this isn't actually going to request a file until you actually call subscribe. And then I'm just console logging the fruit snacks. Event target observable. This is something kind of new, proposed about 6 months ago to WHATWG. There's an issue if you care about this. It's going to add a method called onToEventTarget. And it will also come with a few operators, which is kind of cool. So map, filter first, and take until would be included in this proposal. And it's really simple, right? Basically, if you call the on method with an event type as the argument, it's just going to give you back an observable of those events. So here I'm using the button element. I'm calling on, and then I'm passing in click events as the argument. And that's going to give me back an observable of click events. So that'd be kind of cool. So that's a little bit about just sort of where the standards and reactive programming lives. But now let's talk about reactive programming in different frameworks and libraries. Okay, so I chose 4, D3, Angular, Vue, and React. Obviously, you see these paradigms and patterns a lot more everywhere else. But let's look at D3, for example. So D3 is a great example of it being reactive programming, but them not actually saying, like, hey, I'm going to do reactive programming in D3, right? The code example here is very declarative, which is awesome. It's an awesome sort of like side effect, I guess, of reactive programming. That doesn't actually necessarily make it reactive, though. It's reactive because you're reacting to the propagation of change, right? And you're changing a value's location or the way it looks, but you're not explicitly doing so on every single event. You're just describing what you want to happen under the hood, and then it just happens, which is kind of cool. So if you look at reactive programming in React, let's look at React, for example. So when you call setState in React, it triggers a re-render of the component and potentially its children, right? And yeah, like maybe it's a little bit of a stretch, and a lot of people might be saying like, no, this is totally untrue because it's pull-based. But that's actually also a very common misconception about reactive programming. It doesn't have to be push-based. It can be pull-based as well. So again, if you look at how setState propagates change, the idea of itself in itself is technically reactive. Redux observable, the beautiful logo is Redux. Funny, right? That's why you want to use it. But it uses RxJS to declaratively handle your business logic and side effects when using something like Redux. And MobX, of course, is probably the most reactive example here. That makes your React full-blown reactive programming because your state basically becomes one giant reactive model. And again, this is a great example of something being pull-based, but also reactive. So to be clear, what it does is it just pushes a notification at you, but then you need to pull the values out to calculate the value, which is kind of cool. If we look at Angular, for example, so Angular and RxJS are besties because RxJS is actually a first-class citizen in Angular, which means that the Angular community really gets to benefit from the values of reactive programming. So they have an on-push change detection strategy. And when you enable this, it enables basically more efficient and performant data flow because it's going to push changes at you versus detecting changes. They created NGRX, which is just the Redux pattern re-implemented in RxJS. And then Angular Router, because they use RxJS, you can actually get observables of various events around activated routes. So you can get like observables of changes to route parameters or query parameters. And then forms as well, they're reactive, which means the validation events that they have, well, the validation events are reactive, so it allows the sort of like asynchronous and synchronous validation to blend together really nicely. So there's tons of other really cool ways that Angular benefits from reactive programming using RxJS. Vue, I'm not as familiar with Vue, but they have this really cool thing called, like if you've seen Vue watchers, that in itself is reactive. But if you want to use something like RxJS in Vue, VueRx is a really cool library that just wraps RxJS in Vue to make it easier for you to use. I still use it raw, so I haven't used this library yet, but you know. Anyways, the point of the few things that I went through just now is the idea that, you know, again, I was really excited because I really wanted to learn reactive programming, but I realized after I figured out what it was that nobody actually invented it, right? It's just a name for the pattern of declaratively reacting to this propagation of change. So that's kind of cool. We're just all doing it. We're all cool and hip because we reactively program. And typically where you see reactive programming patterns naturally is where there's a very natural fit for events to be modeled as values over time. So great examples of this would be WebSockets, user events, HTTP requests, animations, network connections, et cetera, et cetera. So we talked about reactive programming in frameworks and libraries, but now I want to talk about how to actually think reactively, because this is where people really get stuck. So to approach reactive programming, you have to think reactively, which means that you should start thinking of everything being modeled as an event, right? And the idea that all web applications are actually event-driven, and everything, meaning any variable updated by an event, can be represented as a set of values over time, even events. So again, this is like one of the biggest hurdles. Some might say, but isn't that just streams? Yes, it is. But let's go ahead and define this really quickly. So when I say set of values over time, I mean set in the math sense, right? And the current mindset, right, is when an action happens, one thing happened. But if you start thinking of things and treating things as sets of values, then all of a sudden you can do really cool things with your data. So examples of sets could be like an empty set, a set of 0, or just a regular set you think about. So again, if everything is a set of values, then you can query it, you can map it, you can filter it, you can join and combine it in different ways. You can give something half a set of things, or get something with a set of parameters. Life becomes awesome. So hopefully that helps you sort of think like, okay, how do I start thinking reactively and in streams? But then it gets exciting because now we can talk about what on earth RxJS is. So how many of y'all have heard of RxJS? Oh, look, I'm with friends. Okay, well, let me explain what RxJS is. So there's a lot of different implementations of reactive programming, obviously. But RxJS in itself is a domain-specific language for reacting to events. So it actually sits on top of JavaScript, and this is one of the reasons why I really like it, because you can take that knowledge anywhere, right? You don't have to go with a framework or library of choice at the time. It's also the most popular reactive programming library. So it has over 12 million downloads per month between RxJS 4 and 5 up, which obviously if it's popular, like these clear shoes Kim Kardashian told me were popular, you gotta start using it. There's also other dialects like Java, PHP, .NET, Ruby, etc. So you know, if your backend teams are using it, it like totally makes sense to use it in the front end, in my opinion. Okay, so let's talk about what an observable is. So there's sort of 3 parts to RxJS. You have observables, observers, and you have operators. And I'm going to talk really quickly just about what an observable is and how observers work with them. So imagine that observables are basically just functions, right? So here we have our imaginary observable represented as a function called myObservable. And the way we call our imaginary observable is by passing in an observer object with callback handlers on it. And the next method is going to be called when an observable wants to emit values. The error method is called when there's a problem or an error condition. And then when the observable is done emitting values, the way it signals it's done emitting is by calling complete. So since our imaginary observable is basically just a function, if we want to use it, all we have to do is call it with the observer object. And it could also just return a teardown function to clean itself up too. So then the question is, okay, well, why not just use functions? Well, because RxJS can actually handle some of the stuff that functions can't handle for you, which really helps improve the developer experience, right? In my opinion, it makes your life a lot easier. So like, for example, with functions, you might accidentally call methods out of order. Like, you never want to call a next after a complete, but observables will actually help you protect you from things like this. Also, if you're just using functions, you'll always have to check if there is a teardown returned or not. And you always have to provide next error and complete because the function is going to expect them. So in this case, the function would just error out because we haven't provided the complete method. And then you always have to call the teardown function on error and complete as well, which is kind of frustrating. But what you could do is you could just take this function and then you could just wrap it in a class that handles it for you. So here what we're doing is we're just wrapping our function in an observable constructor. So this is the most basic way to create any observable. And the observable class is going to normalize all the behavior for you automatically. So it's going to make sure that the observer always has a next error and complete. And it's also going to make sure when you call error and complete that it tears down, it calls any teardown function that you provided, which is awesome, instead of having to do it, you know, directly. Calling it directly. So now what you can do after you've wrapped the function in an observable constructor is just call subscribe. And again, the observer is just going to give you the methods next, error, and complete to emit your values. And so here you can see I'm calling next to emit the values. But the cool thing is, even though I'm not providing an error complete because they're grayed out, the observer will just automatically provide it for me anyways, right? So like, yay, less typing, more guarantees. And then the other great thing about observables is that when you call unsubscribe, it just tears everything down for you and handles cleaning up any memory management. So life is awesome, right? But anyways, this is just a way to sort of illustrate that observables are basically just like functions, but they come with a lot of really cool guarantees to make development life a lot easier. So that's an idea of like what observables are, how observers work. But then the next question a lot of people ask is like, okay, well, what's an operator? Well, an operator just helps you transform one observable into another. So we're already familiar with methods like filter and map that we can use on arrays in JavaScript, right? And these are very similar to what operators are in RxJS. So here's what it would look like if I were to use RxJS's map and filter operators in my code. All I'm doing here is creating an observable of numbers, and then I'm using the map and filter operators and subscribing to the observable with the observer and emitting the values from that observable and logging it out into the console. So yeah, operators are really cool, and it's really awesome that RxJS as a library just does all this stuff for you. But if you really want to look under the hood, here's a simple map operator implementation if you were to create it yourself. And I'm just going to walk through this code really quickly just so you guys can understand what's going on here. All we're doing here is we're simply taking an observable and we're returning a new observable. And then we're subscribing to it instead of calling it like we would a function. And then we're passing along the transformed value and emitting the value by calling observer.next. And then, of course, with observers, you automatically get the methods error and complete if you need them. And so there are tons of operators in RxJS. There's over 60 operators that you can do really cool things with. You probably won't ever have to implement one on your own. And here's a few popular ones that you can start with. My new rap career talks about the share replay operator. Anyways, so we talked a little bit about what RxJS, but then we get to the fun stuff, which is, oh my God, how do you actually, like, how is reactive programming using something like RxJS going to make your development life a lot easier? So with RxJS, you can do so many cool things with much less code, right, once you learn it. So like drag and drop in React Native could be really easy. And it was really easy once I figured out how to do it without document. So here, you see that I created this amazing drag and drop. Oh, no, that didn't work. That was the wrong button. OK, let's see. Let's try it again. OK, here we go. We have a drag and drop, a donut, that I was able to make in React Native, right? And it was pretty easy, so I'm going to walk you through the code so you can see how easy this beautiful drag and drop was. OK, there we go. So first off, I'm just doing my normal imports in React Native, but then I'm importing a few other things from RxJS, like subject and subscription. I'm also importing the different operators I'm going to use, exhaust, map, take until, and map. I'm not going to go into a lot of detail about what every single operator is and does, because we're a little short on time. But I just want to give you an idea of, again, how implementing something difficult like drag and drop could be easy to implement in a few short lines of code. So here, again, I'm just doing a little bit of setup. I'm creating new subjects that I'll be using in my code, touch start, touch move, touch end. By the way, we haven't talked about subjects that much yet, but basically what they are is a special type of observable that are both observers and observables at the same time, which means that they're both going to be able to receive and emit values for you. I'm also creating a new subscription, and then I'm just setting my initial state of the object that I'm going to enable drag and drop in, which is the donut. So when we receive a touch start, we're going to take the value and get the location x and y from it and start listening to the touch moves. And then when we receive a touch move, we're going to map that move event and capture the page x's and page y's of those mouse coordinates. And now we emit an object that contains the page x's and page y's and the location coordinates. And then when we subscribe to that, we're going to go ahead and update our state, and we'll get a stream of touch moves that contains the start location and the actual page x and page y of those touches. And for good measure, basically, when the touches stop, we'll stop listening to the touch moves, and that's what the operator take until will help us do. And now in our render function, what we'll do is first calculate the actual position of the donut. And then we're going to go over here and create an image and use those coordinates for that position. And to actually move the donut, we basically need to wire up our different touch events, right? So in order to do that, we're going to use React Native's gesturing system. And every time there's a grant, we emit a touch start event. Every time there's a move, we emit a touch move event. And then every time there's a release, we emit a touch end event. So that is how easy. Was that easy? I mean, in my opinion, it's easy, but I think it's because I know RxJS. So learn it, and then you can do cool things like this. Or you can just look at my GitHub repo, too. All right, so something probably a little bit more complex where RxJS makes things really easy is things like multiplexing over a WebSocket. And so my problem is I hang out with people who this is like, yeah, you multiplex over WebSocket. And so I was like, yeah, everybody knows what that is. False, apparently. So let's explain what multiplexing over a WebSocket is. So multiplexing in our case is when you're sending and receiving multiple independent requests and responses concurrently over the same WebSocket. So why would you need to actually multiplex? Because it helps reduce the amount of overhead of opening multiple WebSockets when doing things like if you're receiving real-time updates from the client and from the server, or if you want to do something like continuous streaming. So that's exciting, but let's see how we're going to make this really cool thing. Okay, so here you'll see that I have an app that I can click the button and it sends a request to my WebSocket server, and each one of Ken's heads basically represents an individual request from that server. And every little shake animation of Ken's head also represents a new value being pushed to me from that server over one WebSocket connection. Kind of exciting, right? So as you can see, there's a lot of requests being multiplexed between the client and the server at the same time. And by the way, each one of Ken's heads only appears for a short little bit because in my code I've used a timer observable and set it to 3 seconds before the observable completes and unsubscribes from itself. It's cute, right? I like it. Why do we all make fun of Ken? It's because we love him so much. Okay, so I'm going to walk through the code again. So basically we're creating an initial state here of random Kens, which is just an object that we're going to treat as a dictionary to look up our random Ken heads. And then we're making a WebSocket subject here, which is lazy, so it won't actually create the WebSocket in the browser until you actually subscribe to it. And then we have a request Ken head function, and every single time we call it, it'll send a message through to the server through that WebSocket to request a Ken head. And we're going to use that request Ken head later on our little button, the little button I had to request a Ken head. So when the component mounts, that's actually when we're going to set up our WebSocket to listen to the responses. And we know the server is going to send us Ken heads by ID. So whenever we request a Ken head, we're going to get a unique ID back for that particular request. And the server is actually going to continuously give us a stream of Ken heads by ID with animation coordinates, those little jiggles, for that particular Ken head. A little abstract, I know, but it was fun to make. So we want to go ahead and group those so that we have individual streams for each Ken head we request. And we're going to do that using the group by operator. And then when we request a Ken head, we're going to get a new stream for each particular Ken head. So, and then that stream of animation coordinates will animate for 3 seconds like you saw because I'm using the timer right here. Okay, and basically after that, we obviously want to clean that up and remove that Ken head after 3 seconds. So we're going to do that by using the finalize operator here. And now that we have a stream of Ken heads, we can just subscribe to it, and at this point, it's going to kick off the WebSocket, and then every time we get a response back, we're going to update our dictionary by setting state, and if the component unmounts, we want to make sure we tear down the WebSocket by calling unsubscribe. Okay, so now we have a map of random Kens, and we want to get all the values from that, so we're going to use the object values, which will give us an array of those Ken values. And now that we have an array of Ken heads, we can basically loop over that. And for each Ken head, we're going to create an image for him based on the X and Y coordinates we receive from the server. So every time we re-render, we could be like adding a new image, or we could be updating an existing image that was already there. And of course, the button down below is what we're using our request head function for. So hopefully that wasn't too much to take in. One of my friends is like, I'm sorry, you're showing so much code. Anyways, but regardless, you can go through it. So we talked about a few things today. We talked about reactive programming and standards. So looking at promises observable and the event target observable proposal. for reactive programming and frameworks and libraries, right? The fact that we see it everywhere. And then how to think reactively, so thinking of everything as sets of values over time. And then what is RxJS, right? Like what an observable is, what an observer is, how they work together, what operators are, and then sort of how they work under the hood. And finally, we went through a few different examples. So hopefully that showed you how, again, using something like RxJS as an abstraction can make your development life a lot easier. And you know, another thing is you don't have to Rx all the things, right? This is the cool thing about RxJS. You can just dip your toe in and, you know, easily integrate it into your application by maybe like using it for your click handlers, AJAX requests. It allows super easy cancellation if you do that. Anything asynchronous, or you can just call subscribe, get used to it, and then just do your normal imperative code as well and refactor it later on. So one of the things I lead on the RxJS core team is the RxJS docs. So if you want to come contribute, please come play. We always need new open source contributors. It's a really easy library to contribute to, in my opinion. At least the docs are, of course. Maybe not the library, but the docs. And we need like React Native, real-world examples of different things, or React as well. So come hang out. Thank you. You can follow me on Twitter, LadyLeet. I'm always happy to answer questions. And then you can look at my GitHub, and you know, you can get the Node WebSocket server or whatever, the Drag and Drops and Ken Wheeler's Head app. Thank you so much for having me.